was recording. So in the part 2 of the lecture this semester, what we will do is we will take a look on the Qt framework, which allows us to create nice UIs using C and C++, so that we can create interactive applications and visualize data, etc. Usually nowadays any application that you want to use needs to have a nice graphical interface, especially if you would want to use it in a laboratory setting where you want to monitor things in real time, interact with them, etc. So some UI to interactively change parameters, etc. will be necessary. Qt is a framework which is available for free. It can even be mostly used for free in commercial projects. There are only very few components which are not suited for commercial use. So let's see where we can find the free download. Yeah, the download installer. Do you want to download it? Can't we download it somewhere else? Last year the download website was much less annoying. Yes, here we can download an online installer. Windows x68 online. I'll post the link to the chat so that you can follow along. Okay, I will pause the recording for a second. It's resumed. You just say that you accept the license and that you are a single person. Then it needs to download some more data. No, we don't want synonymous data, and then we can select where we want it to install. We only need the Qt itself, so let's say let's go with this one. It doesn't really matter that much. So most of the let's see what we have here. This we don't need, this we don't need, this we don't need. That would be for native ARM, which probably no one really has. And here we have for Visual Studio 2019 and 2022 pre-built binaries. We don't need this. Source is good to have. Debug information is also good to have. These additional libraries we probably won't need. Most of those additional ones are only available under the GPL license, not LGPL. So most of Qt is licensed under the LGPL license, which means that you can use it in closed source projects as long as you either don't alter the open source Qt parts which you are using, or if you alter them, then you have to provide the changes that you have made, but only to those components. Your own code might be closed source. One restriction here is that the LGPL component should be located in a separate DLL and not be statically linked with your project. Some of the components here in these additional libraries are available only under the GPL, which means that your own code must be open source as well. Qt's business model, of course, is that they will sell you a proprietary license such that you can use those components in a closed source project. And let's see what else we will need here. We can take a look here. But I think we have everything we are interested in. So we go next. Accept the license again, we go next, and then it will start installing, and it will take forever. So I have already prepared a Qt before, a bit an older version, whatever I just had at the moment lying around. I already unpacked it. It's the 6.5 version. Here we have only the 2019 binaries, but this is fine since our Visual Studio can compile also for the older one. And the other thing what you will need is the VS add-in for Visual Studio. This can be found also for free in the Visual Studio Marketplace. The network is turned off. Second result, and you of course need to pick one that fits your actual Visual Studio version. So if you have Visual Studio 2022, what is the latest one that you can get, then it's here. There is a version for ARM, so for the new laptops that have been recently released. If you want one of those, and of course you can also download one for the older version if you would have an older version. I already downloaded one, so we can install it to our Visual Studio. And we of course need to close it before we can add the plugin. Okay. When we start Visual Studio, first we continue without code, and it tells us here that we need to select a Qt version. You can find the settings also independently, but for now let's go from here. So we select that, and then we browse for our Qt installation. So you go to Qt, the version that you've installed, the binary type that you've installed, then bin. We are looking for the folder where this qmake file is, and then once it's here, we just press OK, and we are done. This we can remove, and if you want to add other versions, you can go to extensions, Qt versions, and it brings it to the same place. And for every Qt version that you install, you have to add it here, otherwise you cannot use it in Visual Studio. Okay, so let's now create a new project. And as you see here, we already got quite a few new project types. So language, we select C++, platform, Windows, project types, Qt, we select those, and we can of course create a Qt console application, which in this case would be a bit boring. So what we want is a Qt widget application. There is also this Qt quick application thing, which also would give you a graphical application, but there it is more optimized to create like very modern using UI, which also means that you would need to put much more work into creating a functional UI. So for some applications that might be desirable, but for our for function over form approach, we go with the old style Qt widgets application. Qt UI test, let's call it, and we press create. Then we get a new window from the plugin which we installed. Again, it asks us which version. Here we can select modules. If we click here, we get a whole list of different modules which we can add. By default, so Qt core is always needed, Qt GUI for graphical ones, and Qt widgets because we're using widgets. The other graphical type would use one of this this one, Qt quick, and Qt QML, I guess, would be mandatory. But for our use case, we are happy with just those three. We could add, for example, network. That might be interesting. Qt serial port might be also interesting. So for when you think about lab applications, a lot of hardware can be communicated with using serial ports. So that's that. Of course, for the test case, we won't use much of it. We'll just test UI. And in the last window, you can select the names for the files that will be created by the wizard. You can enable the use of precompiled headers. This is quite recommended, as when you're using precompiled headers, then the compile time of your project is greatly reduced, so everything builds faster. We could add an icon or use here this lowercase file names, which I don't like. I prefer file names to have uppercase. So that's all we need to change. We can press finish, and it will create an application for us. As you see, there are quite a few files that have been created. We have a main CPP where we just have the main function, which gives us the command line argument with which the process was started, and it instantiates a few objects. First, it instantiates this Qt, so this Q application, which is the main part of a Qt application. This thing is derived from Qt GUI application, which again is derived from Qt core application. So if you would have created a console application, then we would use Qt core application instead, because all the other graphical things would not be needed. And then we have our own class, which implements our first window, which was created for us, Qt GUI test, which gets instantiated here, and then it's shown, but it's not really shown at the moment when you call show. It will be just set to be made visible, and then we are starting the main event loop for the main thread in our application, which is handled by the Q application object. So now let's take a look into the other class. As you see here, it's quite small. We include some header, then we include a machine generated file, and then basically the only variable here is this UI variable, which is an instance of a machine generated code piece, which we then just here connect with our own object. And this machine generated code gets created by the plugin based on the UI file that we can hear in a graphical editor design. Internally, this UI file is an XML file, and whenever we change something, then the corresponding file, this one, gets recreated with new members added. So we can take a look how this looks internally, and as we see, the machine generated code is quite short for now. It just instantiates a menu bar and a status bar, and that's it. So let's take a look here again. So we have here the menu bar where we could add menu entries. The status bar is at the bottom, and in the middle we can drop all these different widgets. In principle, you can add your own widgets here to the sidebar, but I usually find this too much work. It's easier to, if you have custom widgets, to just have a placeholder empty widget in your window and then just swap it manually. That said, you don't even need to use this designer, as it compiles everything to C. Obviously, you could just write the C code yourself by hand. And my general approach here, whether to create a window manually or whether to use the designer, is usually that for simple dialogue, so things which don't use custom widgets, which are just trivial, I usually use a designer, and for more complex UI components, I'm just writing them manually in its entirety. That may look like a bit more work initially, but giving a much better structure, it is, in my experience, often even faster, because with this graphical thingies, if you want to make it more complex, and you move things around and adjust them, and that's just takes a lot of time, while if you do it programmatically, it's often faster. So here, let's say we will want to add maybe a text edit, and then let's say we want to add a few buttons. As you see, we can select from, if we have a push button, we have a tool button, and a few other button-esque types. So let's just drop a few buttons in here, and as you see, for now it's all kind of unstructured, so if we resize it so nothing happens, so that's not really how you would want a modern application to behave. So what we do now is we will define a layout, and let's go with a grid layout. And now already you see the things have been aligned, so let's add a few more components, a space, and then we can of course make any widget take as many cells in our grid as we want. The other layouts which are generally available is horizontal and vertical layout, which is quite trivial. You can in principle use a grid layout here always, but it simplifies things. You can use a form layout, which is just a 2 columns and as many rows as you have. And in principle, you could also define some very own layout. I see there are some questions in the chat. So for okay, I finished this, and then I will look at the questions in the chat. So as mentioned, you could create your own custom layout if you want, but I never seen the need for that. So if we now save this and then take a look here, as you see, the file has changed a lot and a lot of things have been added. And last thing, let's just run it. So that again will take, the first compile always takes longer because it compiles all the headers, but then subsequent compile should be faster. And voila, we have our application with a UI. So let's see the questions in chat. So first question is whether CLion can be used from JetBrains on Mac OS X. I don't know if CLion supports Qt. It might do it, but if not, then if you install Qt on Mac, then it will install. Well, we didn't do that here, but there is this Qt Creator tools. Qt Creator bin, which is an own IDE which can be used instead of Visual Studio, and of course it can be used on any platform. So Qt Creator is created in Qt, created for Qt, and you can use it on Mac, you can use it on any Linux that you get Qt for. So if your CLion does not support Qt, then just use the Qt Creator. It works on Mac quite well. The next question is whether we can just write the XML code. In principle, yes. So let's close this window. Let's go on this file, open with XML text editor, and this is pretty much the content of the UI file. So let's see, we have here this push button. So let's say first one will be new, call it new file. Position, as you see the position, maybe this one should be the new. The other one will be open. So we'll make a very simple text editor just as a proof of concept button. Open file. The last button will be button save. Save file. Okay, so we have edited here the XML. We save it, and then if we open our UI file, as you see, the changes we have made are applied. So by the way, this thing can also be run in an own window, which actually I prefer because it gives you kind of more space, because here you kind of lose space because of the sidebar. So opening it in an own window is quite convenient in my opinion. Right, we didn't give this one a name, so text. As you see, any element will get a automatically generated default name, but obviously those are not very helpful. So it's the first thing you should do after you have created your and placed your controls is to give them reasonable names that you can easily use. Okay, so let's close this and go here. Okay, so one important thing about Qt is the Qt documentation. Why is that old one? There's the yeah, so all classes. I'll put the link in the chat as well. And here you have all the objects which Qt uses described in detail. So for example, here we have our new button. So when we take a look what this is, it is a QPush button. So we can take a look what QPush button is capable of. So we see that it's derived from abstract button. A lot of things are derived from abstract buttons. So radio buttons, checkboxes, etc. So here we don't see much. So let's now take a look on the abstract button. When we scroll down, we see some signals. Signals and slots in Qt are the main mechanism how you can connect different objects with each other, even if they are internally not aware of each other. So it is quite a useful mechanism. And this, you can think of signals like events that are emitted when something happens, and slots as handle our callback function, which are invoked by these events. So in this case, we would be interested in the pressed or in the clicked signal. Toggled is when a button changes its state from being pressed to being released. So, for example, a checkbox can be checked or unchecked. A radio button the same, and a normal button can also be either work like a momentary button, like on a keyboard where you push it and when you release it, it's released, or like a light switch. When you press it once, it's pressed, and when you press the second one, then it gets released. So this will be toggling the button state, and we can, when we open this quickly here, this on the settings here, there is this checkable checkbox, so we can make even a normal button behave such that it can be toggled between an on and an off state. But for this application, we want the buttons to behave like momentary buttons, so it's fine as is. We will take the clicked signal, and now let's see how we use it in our application. So we need to go to the definition of application and define slots. So as you see here, by the way, already there are a few things which do not exist in normal C++. So for example, this QObject or private slots, it's not a keyword that in C++ would normally exist. When you click on it, it is just a definition of something else, which at some point, if we go far enough, is defined as nothing. So it's kind of, for the C compiler itself, it's basically nothing, but Qt has an own meta object compiler which goes through the file and finds, for example, slots, signals, and stuff like that, and generates a few more machine-generated files before the actual compiler starts. QObject here is a bit different. As you see, it actually adds quite a few additional members to the object, such that the Qt mechanics can work on it. So it's not super lightweight. So every QObject, as you see, has quite a few things added. But all in all, it's a worthy trade-off. So you get much more functionality than what you are losing on more memory use and computational complexity of the whole thing. Okay, so we have defined here these slots. So let's create some void on new and on open and on save. The names you can choose as you like. There is no fixed convention. I just like to call slots on something because they are triggered if something happens, and they're just normal functions in the implementation of your class. Okay, now of course the interesting thing is how we connect them. There is a function for that called connect, which takes a few arguments. So the in the older Qt versions, all these functions worked mostly identical. There was just an object, then a signal, then again an object, and then a slot, and that was it. And in modern Qt, because of the new features of modern C++, this changed. So you see that there are quite a few different connect implementations, and you can use instead of a object that has a slot, you could use a lambda function, for example. So this on one hand adds a lot of flexibility to the code, but also makes the Qt implementation a bit more convoluted. So as mentioned, we need a sender, so new signal. We copied the signal some time ago. So the signal needs to contain the argument list. The reason is that we can have we could have multiple signals with different argument lists. So we need a list here, and then the receiver will be this, then slot, and let's go with on a new. And what you can see here is that you can drop arguments. So if this one has this boolean, which tells us whether it's right now active or inactive, so checked or unchecked, our slot can just not care about it. So let's replicate this also for the other ones. Open and save. Okay, let's put breakpoints there and let's run it. We can check on the output if it complains of something. So if we would mistype the names here, it would not fail during compile, but in runtime when it executes it, it would say that the slot doesn't exist or a signal that doesn't exist. So if we press, let's say, new file, open file, then it reacted and opened it. I also have noticed that we should move a new file there and have open file on this side. That is nice. Yeah. New open save. Yeah. Or yeah, that is usually how those are. Okay. One more thing maybe to test is that when we click here, we can take a look on the call stack. So how this event was triggered, and as we see here, the button internally got at some point an event on which it executed. Well, it called then a few more event handlers, and at some point it initialized the don't click, the emit click, and then finally let's see what the source code is. Qt. This will be somewhere the widgets. Part of base, maybe it's part of base. We're missing some source code here, maybe. It looks like we don't have all the source code for some reason. Yeah, that is annoying. Usually this is always complete. I don't know why it isn't this time. Or maybe it's somewhere in base. No, the problem is that this is one of these generated files that will not be included. But we can use at least the file that called the generated file. So as you see, at some point it has an emit click, but the click itself, as being a generated file, is of course not included in the source code itself. Okay, so let's close this for now. So this is all quite efficient actually. The way a Qt works is that you could connect signals and slots also across different threads, in which case the mechanism to invoke the signal will get much more complicated. That is also quite useful, so this will be the next thing we will take a look at. So let's create a new project. This time let's go with a console application, so we don't want a UI. Qt core test. We can add the same things we did the last time, although we won't use it properly. Okay. So as you see here, it is much simpler. It just creates this application. And that's it. Before we take a deeper dive into the signal and slots, is everything about this part clear so far? Or do we want some more details on one of those mechanisms? Okay, if there are no more questions, then let's continue. So obviously, so that this will be interesting, the first thing we want to do is we want to create a new thread. Let's call it C. It's derived from QThread. We need to add the QObject definition, and we will need to create a constructor. The constructor doesn't need to do much, but there is one thing we should take a look at. When you see here, QThread is derived from QObject, and its constructor has here this parent object. And if we go on object, it also takes a parent object. So in principle, every Qt object can have a parent, and this is quite helpful to manage resources. So as soon as you delete a parent object, all its child objects will be destroyed as well. So we want to maintain this functionality with our own thread as well. There is a second memory management mechanism that Qt offers, which are smart pointers. They are quite similar to what you get nowadays with the smart pointers that you have in the standard template library. The functionality is quite similar also with newer. So while Qt in older versions had own implementations of many things, with newer Qt versions they try to wrap standard objects as STL components as far as they can, so that their own code gets less redundant. And you can also expect that implementations in the STL, whenever possible, will be available for many platforms, so they could easier then port their code to other platforms as well. So this thread obviously still is not doing much, so let's add a slot to it. Let's call it slot 1, and let's give it anything, it's fine. I like that. But what we will also need is we will need another object to connect to. And let's include QDebugged. So here we just want to notify and print to the console that we have reached the slot. And to be able to call it, we need something else. Actually, that gets a bit more complicated. We need more objects. So let's create some additional classes. Let's call it scene. Class which will exist in the main thread, and then let's create a thread class which will exist in our thread. Oh, no. Because threads you always need to create yourself. There are some mechanisms that allows you to use thread pools where threads are created automatically, but for most applications, you just write the application, and if you don't do anything special, then everything will just happen in the main thread. And if you want to run things in parallel, then you need manually to create new threads in which you will outsource part of the operations. And to make things even more complicated, you will need to also manage the accesses. So if you have data structures which are shared between multiple threads, then you will need to ensure that the states of these objects will not become inconsistent. So you will need to log access such that at any given point in time, only one thread can work on a data set. And then when it's done, it notifies other threads that now another thread is allowed to do some of its own modifications. You're welcome. Okay, so we have our few threads here, like the main thread. Let's just add a few things to it. So each of them will get a slot 1, and like here we will just copy everything, just that we need to rename it. And that's QObject. Okay, and then we also need signals. And for signals, you don't write a function body. So the content of my signal will be in one of these mock underscore files which are generated by the compiler. Okay, so we have our three objects. Now they don't do much, so let's go to our main class. Let's include them. My thread and my this was just main class, and thread class. Okay. So we create just an instance of T, or we call it my thread, and we create an instance of it's a main class, my main, and an instance of the thread class, my my thread we already have, so my class, let's call it. Okay, so as already mentioned, everything that starts in main is already located in a thread, the main thread of the application, and Qt is made such that every QObject is associated with a thread, and by default it is associated with the thread in which it has been created. So currently all the objects here belong to the main thread, even though here we have already created a thread, although this thread is not yet running. So so to make it run, it needs to be started. But what we can do even before it is started is we can we move to thread and specify a thread we want our class to be in. This needs a pointer, so we go with our reference. And here, now we can connect it, so we can be a bit lazy and just copy our connect line from here. And of course the sender will be now, let's say, our main class. This doesn't have arguments, and was called mySignal1, if I recall correctly. And then of course we connect it with the my class, with my slot1. And so connect is defined on a QObject. So if we are outside of everything, we need to specify the namespace. So it's all the connect and disconnect functions that Qt uses are static functions defined on the QObject object. So we have the connection here. We can start the thread, so the thread will be already doing its thing. And at some point we can just hit my main, my punct, my signal1. Again, this emit is a non thing, so we could just write it like this. And in contrary to signal and slots as defined here in the header, the emit here is completely not needed. Qt's meta-object compiler is not looking for it. I mean, I don't know whether in very old versions 20 years ago they maybe needed it for something, but nowadays it is just used to indicate that you are invoking a signal, so just for the user, like a bit less obvious comment, so to say. Okay, so we can just run it. To open a console window, and it should print that we have arrived thread class slot1. Now, if we put a breakpoint in thread class slot1, we will see that we really are in the other thread. So maybe I first put another breakpoint here or anywhere. So we see that the main thread of a process, so we start in the NTDLL, then we do something in the kernel 32 DLL, and then we enter our own binary. There is another main function, main.cat startup, which does many things. It sets up static variable contents and stuff like that. And ultimately at the end it calls our own main function. And when we run to the next breakpoint in the own thread, we see that while we start also in the NTDLL and kernel DLL, here we directly start with the thread start function inside the Qt framework. So we are really in a different thread. And we can also see here the list of threads available. As you see, there are 2 additional threads which I haven't mentioned yet. These are created by the loader in NTDLL to load other libraries in parallel, and they usually get terminated after some time when we have not loaded any new DLLs, so they can be safely ignored. And as you see here, we the call path is different. So when you are calling, when you are connecting a slot like this, when we go to the definition of connect, we will see that there are other ones which also allow us to specify here this connection type. And there are a couple of connection types. There is this direct auto connect, obviously, which is the default. In this case, Qt will pick which connection type it should use automatically. And then we have direct, queued, and blocking. The other ones we don't care about. And direct means that the connection will bypass the event loop, and direct connections can only be used when the thread which invokes emit, as well as the thread that is connected to it, live in the same thread. As in this case, as you have seen in the UI test, it is quite a direct call path, so there are a few functions in between which get invoked to dispatch the signal, but the event is not queued. The event here is blocking, and it is generally has quite little overhead. If, however, the two objects are in different threads, then Qt will choose queued connection, which means that the emit signal will terminate instantly, and the slot which it is connected to will be executed at some later point in time when the other thread has time to do so. And blocking queue is comparable, just that there it actively blocks and only continues once the other thread has finished. So we could add some more threads, and for example move one of the objects to the other thread to demonstrate this. But before we do that, there is also another mechanism how a signal can be a slot can be invoked. That was it? Invoke method. That will be my class again. Comma here. This time we only provide the name of the slot and just as a string the arguments currently. So we could provide an argument list, and what we also can of course provide is the connection type. So by default is again auto connect, and effectively when you look on the insides of such a signal, it will go to a dispatcher which will automatically use such a invoke method on the right object. So when we run it again here, then again we arrive at the slot. So here it looks just the same, but we have saved some overhead and not went through the additional dispatcher. This invoke method is quite useful, especially when you combine it with a blocking call, because it allows us also to wait for a return value. So in this way we can effectively call a function on another thread and wait for its result. That is generally quite a useful capability, as then we don't need to write our own message loop, etc. Let's take a look on how this thread works. So again, if we run it once more, when we go through here, we see that on this thread we have here this run function, and then we have exec. Exec we already know from here. So exec starts an event loop. On application it starts the main application event loop, and on the thread it starts just the event loop for this single thread. And of course we might want to create a thread that does something before it starts its event loop, or maybe even a thread which works completely without an event loop. This all is quite easily possible. We just need to go to the thread, and provide an own run function. So when we go to qthread, we see that it has a virtual run function, and internally this virtual run function just calls exec and doesn't do anything else. So we can provide our own, and of course if our own function would not do anything, then when we run out the application we just terminate without doing anything. So actually it doesn't terminate because it's stuck in the, where was it, in this thingy. But we can close it. The thing is, it did not invoke slot 1, so this function queued the operation, but since exec was never called and the event loop is not running, then nothing happens. So we can here now either just run exec of the thread, run exec of our own thread, or we could also use qthread run, or whichever we prefer. Let's put a breakpoint here so we take a look how it is implemented. Since we have the source code, we should yeah, so as you see here, the run just calls exec and doesn't do anything else. So here it's really up to us how we do it, and now when we run it, we see again we arrived at our slot since the exec was again invoked. So the nice thing is that here in the run we could initialize some additional object which we want to use. And some things to note about these threads and objects is that the thread itself by default belongs to the thread which created it, and thus also to the object that created it. So a thread should not kind of belong to itself, so you should not make things like move to thread and then move the thread into itself. That is not how it is supposed to work. Okay, are there any questions at this point? Okay, if there are no questions, then let's see what else we could quickly test. For example, we could use this slot to tell the thread that it should terminate itself. So we go to our thread class here. To include the thread quit, and then the thread will terminate. And let's see for the thread class, let's add a destructor as well. And let's do some more things. So let's go to main thread. And here let's do okay, radio. And as you see, the thread started, the slot was invoked, and then the thread terminated. So on the thread, if you call quit, quit by the way is I want to see the definition in the header file. As you see, quit is a slot, so it can be also invoked from different threads quite conveniently. And there also is this terminate and exit options. So exit does is similar to quit, just that you can specify a return value which then exec will return. Terminate is different. Terminate does not like end the thread gracefully, but it just kills the thread. So if the thread was supposed to deallocate some resources, then it will not be able to do that. So in your normal program, you should never use terminate. You can use it like as a fallback, so that you tell a thread to quit or exit, and if you could, and then you wait for it to finish. So there is here these wait functions which you can use. They will lock until either a timeout occurred or until the thread actually has stopped running. So for example, you could tell it to quit and then wait a minute for it, and if it is stuck, then you could decide that you prefer to terminate it and have some resource leaks or potentially a crash further down than to lock the application forever right now. So there are use cases where such terminate is fine to use, but generally it should be avoided. Okay, and since my voice is getting worse, I think for today we'll end here. We'll try to catch up during the next lecture, so I might go a bit over time. But for today, I think that is a good start, and during the next lectures you will also get the opportunity to do something on your own. I won't give you any homework today, since I think we are not far enough for that. If you have any questions, you can ask them now. Yeah. So are there any questions? Well, first of all, all the normal code that you write runs in the main GUI thread. It doesn't run in a separate thread, and Qt also does not create a separate GUI thread. Your main thread your main application thread is the GUI thread, and unlike on Windows, you can only have one GUI thread with Qt. So on normal Windows, for example, you can create one thread for each window that you create if you want. You don't need to serve all the windows from a single thread. In Qt it's different. In Qt you only have this one main thread, and this means that if you have some work which takes longer, then it is a good practice to create your own worker threads to which you then outsource the work. Using async and await is only available in the very newest versions of the C standard. You don't have such mechanisms in older versions, and most C projects that you will encounter will not use such automated means of putting things into other threads. So most of those will just be normal projects where people actually create their own worker threads and then feed them operations and try to keep the UI only busy with the UI and nothing else. Any other questions? Yes? Well, because most people are not using the newest features right away, so and a lot of projects that are in use nowadays have been written over 20 years ago. So Qt itself is like probably about 30 years old by now. And if you look on many of the other libraries that are available on the internet, they are all written with C98 in mind usually. So sure, if someone would now write a complete new library from scratch, then they might decide to use these new language features. But you also have to think about that when the standard comes out, doesn't mean that all the compilers will support it out of the box. So especially Microsoft is rather, or at least in the past, they were rather slow with implementing those standards. So um, they may also be implemented buggy. So generally, you would not want to use the newest standard when you want to make something that is intended to be production code. So you would use something that you know that will work reliably. Mm-hmm. Yes. Yes, yes. They are not linked to each other. So in the exercises, we are just exercising C++ skills, while here we will be looking on using Qt in particular. There will be homework assignments, and depending on how fast we progress, you may also have the opportunity to do some things during the lecture. Yes, I will. Probably during the next lecture. Yes. Any more questions? Okay. So if there are no more questions, then I'll stop the recording.